You're waiting in line at Disney World, ready to go on your favorite ride. You look up, get nervous from the steep fall of the roller coaster, and suddenly trip as the line moves forward. Great, you just fell in dog shit. Who in their right mind takes a dog to a theme park? Hello there, Kyle. Here, let me clean that up. You look like a mess. Seeing as this is your favorite roller coaster and that you are obsessed with wild rides, let me take you to an even better theme park. One where you fall into extreme space objects. Literally. That way you don't have to worry about eating poo and can simply enjoy the violence of the universe. Besides, I'm not tall enough for this ride anyway. In fact, we're going to experience what it's like to fall into 9 of the most extreme space objects I could find to ruin your theme park obsession forever. Starting with an absolute monster, an O-type supergiant star. These are the biggest, hottest, baddest, and most unstable stars in the universe. And they are literally born this way. Not like the other giants who only get to this size when they're old. O-types are so extreme on classification charts, they literally edge it. See, these stars are so massive that their own insides are trying to blow them apart. Like both our love lives, Kyle, it's a disaster. All stars exist because the pressure from their fusion counters the force of gravity that is trying to collapse them. When it's balanced, we call this hydrostatic equilibrium. Like when you ate just enough pizza so you're full, but not throwing up. Definitely not based on a true story. But because O-types are so extreme, this balance is always fluctuating. It can cause them to pulsate wildly. Every few minutes to days, they literally swell and shrink, like they're breathing. Except their breath is plasma and death, which is still more pleasant than your breath right now, Kyle. You know what, brother? Have a mint, please. Anyway, we're not here just for the science, it's time to fall on the dang thing. First, as you approach, radiation instantly fries everything, and this would normally already kill you. Except not in this video, otherwise it would just be a YouTube short. So after you survive this, because we said so, ultraviolet rays, X-rays, and stellar winds, moving at thousands of kilometers per second, start stripping away the outer layers of your spacesuit. You plunge into the outer atmosphere, if you can even call it that. See, despite the star's insane size and mass, its surface gravity is only about 3 times as much as Earth's. Which means that yes, you will fall onto the surface, but it won't kill you instantly with some kind of hypergravity. Instead, you find yourself caught in a turbulent plasma ocean where pressure skyrockets every second. And then you fall through the surface. Midway down, you enter a new kind of hell. Hot plasma violently rises and falls, trapping you in a chaotic tornado of gas. Radiation pressure builds faster than gravity down here, and before you even get close to the core, the temperature soars past fusion thresholds, tens of millions of degrees. Not even your suit can hold. Your body disintegrates, atoms torn apart by sheer heat and pressure. You don't hit a solid surface, you're simply absorbed. What's that, Kyle? Yes, the ride ended before it even finished. Talk about an anticlimax. That was even worse than the finale of Game of Thrones. But you know what? Let me make it up to you. Our next fall will be into an extreme space object that you can actually reach the surface of. Say hello to the white dwarf, the burnt-out core from a star like the sun left behind at the end of its life. It's literally a stellar corpse the size of Earth. That means the surface gravity is ridiculous, around 400,000 times stronger than Earth's. As you drop towards the surface, there's no fiery plasma ocean or blinding radiation this time. It seems cold, silent, until it's not. Yes, as you approach, you realize it's as bright as the sun. You accelerate faster and faster, hitting speeds of thousands of kilometers per second in freefall, since the white dwarf's gravity is compressing space-time around itself like those people who put on tights to go to yoga 3 times a day, and then bam! There's no cushion here. You hit the surface, and it's solid. Solid degenerate matter, supported by quantum mechanics itself. The impact isn't a bounce or a splat, it's a merger. Your body doesn't just break apart, it compresses into a thin film of plasma spread across the surface like Marmite for stars. Except that Marmite is spread 1 atom thick. Your atoms lose their identity, get squashed by gravity and pressure into a searing hot puddle. Congratulations, Kyle. That's what happens when you belly flop into a dead star. The good news is that you finally reached the surface. The bad news, you are the surface. Yeah, wasn't that awesome, Kyle? What a rush! That made Six Flags look like a joke. Well, good news, your next ride awaits.
And it's even worse than the last one.
Which means we need to protect you a little bit with knowledge, because today's sponsor is Brilliant. This is my go-to app for actually learning science without needing to actually land on white dwarfs. Brilliant helps you get smarter every day with thousands of visual interactive lessons in physics, astronomy, math, programming, data analysis, and even AI. But here's the real power. Brilliant builds your critical thinking skills through problem solving, not memorization. This means that you're building real knowledge on incredible topics and you're becoming a better thinker and a smarter thinker. It's also really simple to use with its encouraging tips, starting you with the foundations like, say, understanding planets, and then helping you level up to increasingly challenging problems like understanding black holes. Personally, I've been loving the coding courses lately so I could create even more extreme methods of finding objects to torture, to take Kyle to, using Python, a very important language in astrophysics. You can try everything Brilliant offers free for 30 days at brilliant.org/gravipool. And once you're hooked on learning, you'll also get 20% off the annual premium. Now that you understand how I found this next ride, Kyle, say hello to the neutron star, the white dwarf's scarier and heavier brother. Same deal as before, a dead star, but this time it's been crushed so far beyond a white dwarf that it's basically a giant marble floating in space made of a gazillion neutrons. It's about 1.4 times the mass of the sun, but squeezed into a ball just 22 kilometers wide. That's larger than Orlando, by the way. Take that, Disney World. Also, don't worry, the surface gravity here isn't hundreds of thousands of times greater than Earth's like white dwarfs, luckily. It's 100 billion times stronger than the Earth's. Yeah. As you fall towards the neutron star, you start accelerating so fast that your speed becomes relativistic. We're talking fractions of the speed of light in just seconds. But the real problem isn't speed, it's what happens to your body. You've heard of spaghettification near black holes, right? Well, this is spaghettification light. At about 50 kilometers altitude, the tidal forces here are so extreme that your feet are pulled towards the star thousands of times harder than your head. You don't stretch, you shred. Your body rips apart layer by layer as you approach, as if I were cutting you like sashimi one part at a time. Slowly having your human pieces splattering on the surface one by one. Except it's not really a surface in the way your brain can understand. See, while white dwarfs are made of tightly packed atoms from leftover carbon and oxygen due to intense gravitational collapse when it, died, this collapse only stops going further because the electrons get so close together it's impossible for the white dwarf to get smaller. Neutron stars take this a step further. The protons and electrons in the star actually smash together, creating neutrons, forming a solid ball of pure neutron nuclear matter with no empty space left at all. This process means we now call them degenerate electrons and degenerate neutrons. So yeah, you could merge with the surface just like you could with a white dwarf, but if you happen to be heavy enough and going fast enough, you could be absorbed into the star's degenerate neutron soup. Your life would finally have meaning. But you know what is even better than becoming degenerate neutron soup? Being torn to shreds in a giant space blender. The Magnetar, a special type of neutron star that's basically a death magnet. Same size as before, but with magnetic fields a quadrillion times stronger than Earth's. And that's not an exaggeration. The magnetic field here is so strong that it can literally tear apart atoms. No gravity needed, just pure magnetic violence. Your very atoms start stretching into weird shapes because the magnetic field is forcing the electrons to spiral in unnatural orbits within your own atoms. Your molecules unravel, you become a plasma mist, and the star's gravity pulls whatever's left of you into its crust. You don't even get the dignity of spaghettification here, you just dissolve into magnetic dust long before the surface. But now, the grand finale of our wonderful day of theme park fun, presenting Black Hole City! We have amazing rides, 3 different kinds of black holes, and many ways for you to fall into your demise. Are you ready?
Let's go.
Let's start with the smallest, one you've never even seen before, a type of primordial black hole. This isn't your average dead star. It's a black hole that was born at the dawn of the universe. Maybe. Possibly with the mass of an asteroid. Probably. But squeezed into a space smaller than an atom. Yeah, you can't even see it. It's basically an invisible death trap drifting through space. Like being one of the 3 blind mice and smelling cheese. They probably should be careful. No, don't do it! Well, anyway, as you fall towards this particular primordial black hole, nothing would really happen. No radiation, no heat, no warning. You just fall faster and faster, like those dreams where you are free falling, and then instantly everything is over. You're swallowed whole in a single moment. There's no stretching, no time dilation, no dramatic fall. You just vanish into an invisible microscopic point of gravity. Woo! Isn't that fun? Let's up the mass and the size. Say hello to your first real black hole, the solar mass black hole. This one is made from a collapsed massive star, usually from 8 to 10 times the mass of the sun, packed into a sphere around 30 kilometers wide, that's smaller than a city but with the gravitational pull of an entire star. As you fall towards it, it's not like the others, Kyle. No. There's no heat, no magnetic field, no surface at all. From far away, it's just a dark sphere surrounded by glowing gas in the form of an accretion disk. Yes, it's eating its own skin from when it was alive. Damn. But the closer you get, the weirder it gets. Time starts slowing down for you, and to anyone watching it from far away, it looks like you're just falling in slow motion or completely still as you gradually fade out of existence. But from your perspective, the universe on the outside speeds up. 1 second for you, 100 years for Earth. You'd also just be falling normally with your special suit until you're near the event horizon. And then boom, spaghettification. And not that light from before, real spaghettification. The gravity here is so extreme that your feet are pulled towards a black hole way faster than your head. Yes, like before, but just stretch thinner and thinner and stretch into a long glowing thread of atoms as you fall in deeper and deeper. If you survive this, because once again, it's a YouTube video, and cross the event horizon, there's literally no escape. See, the event horizon is not a real surface. It's the limit of where even light can't escape the gravity of the black hole. Every direction now leads towards the center, the hypothesized singularity. There could be many versions, but we're going to focus on the one. You're doomed to keep falling until you actually hit it. This is where space and time themselves break down, and your existence ends in a point of infinite density where all the remains of the star are compressed, and that's only the smallest real black hole. The next ones? Oh, you'll wish you were stretching like a noodle. Introducing the supermassive black hole. These monsters sit at the center of galaxies millions or even billion times the mass of the sun, with event horizons larger than entire solar systems. They're the heavyweight champions of gravity. But here's the twist. This one doesn't feel as scary, at first. In fact, as you fall towards it, nothing really happens. It's what we call a gentle singularity. You can even cross the event horizon without noticing anything weird at all. That's because these black holes are so huge, the tidal forces at the edge can actually be pretty weak. Similar to how the large O-type star's gravity was also weak far out from its core. Spaghettification doesn't even start until you're way inside. You're falling deeper and deeper and deeper as the universe around you shrinks into a tiny point of light above. Eventually though, Kyle, there is no escape. No matter where you try to move, every direction pulls you towards the singularity at the center. And when you finally get close enough, yep, your fate is sealed. Everything about you, everything you were, everything you've ever known, gets crushed into a single point beyond comprehension. You didn't stretch into spaghetti this time, you just quietly vanished inside the largest black hole in the universe. Oh, you think we're done here, Kyle? No, we've saved the weirdest ride for last. The final 2 attractions with theoretical physics still can't figure it out. A marvelous wonder of unseen, unhinged physics. First up, the boson star. This thing isn't made of normal matter at all. It's a hypothetical object made of pure quantum fields, maybe even dark matter, held together by gravity and quantum mechanics. A quantum field is basically an invisible energy field that fills space, and this entire star is made from it. No atoms, no protons, just a giant blob of exotic particles that are invisible. And here's the weird part. These particles are called bosons. Unlike normal matter or the stuff you can see, they can exist in the same place at the same time. Like your chair and table could be in the exact same space. And as you fall towards the star and you just keep falling through weird energy fields that stretch and warp space, it's like falling into a gravity trampoline that never lets you stop bouncing. You don't even die, you just dissolve into the star made up of what's called a Bose-Einstein condensate, permanently stuck, vibing with other bosons. You're now just a wave function. But wait, the final ride is here, and it's even worse. Do you remember the strange star, also known as a quark star? This thing is what happens if a neutron star goes even further, stronger, faster, insaner. Gravity crushes it so hard that neutrons themselves break down into a sea of quarks, the most fundamental particles of matter. You fall in expecting a repeat of the neutron star, but nope, this thing converts you like an evangelical at your doorstep. The second you touch the surface, your atoms are forced to join the quark soup, transformed into strange matter in an instant. No splat, no burn, just instant cosmic assimilation, like the worst space virus you can possibly imagine. You scream in pure agony, but no one can hear you. Sound just doesn't travel through space. Or does it?